started. Thank you for coming to this is the second webinar in the year 5 of the Trees Around the Globe Student Research Campaign. This is actually webinar number 51 for the campaign. I should say 51st regular webinar. We've had a couple special webinars with different globe regions, but this is a 51st webinar for the regular webinar for the campaign. And today we will be having a student research by example with Croatian students discussing their tree research and its real world applications in the city of Karlovac and Dubovac districts. And we have some great teacher and students ready to present in a couple minutes. But first, let me go over the agenda today. You'll see here, I'm just going to do a little webinar intro and metrics. A little bit about an update about the current NASA Globe Trees Challenge 2022, Trees in a Changing Climate. We will then have a feature presentation. And then we have a couple things we're going to talk about, looking at ways to research. We're going to have our own Autumn Burdick, who many of you know, probably all of you know, talking about the Globe student vloggers. And we're just looking at different research methods. They did research and looking into trees, and they had an assignment that Autumn will talk about. And then we're going to pass it over to Peder Nelson, and he's going to talk a little about online tools and, potentially some of the things, Peter, I believe, maybe about some Pecora stuff that you were at last week, maybe 2 weeks ago. I'm losing track of time. And then we're going to talk briefly a little bit about the UN Sustainable Development Goals, just a quick intro into them, because Peter Falcon was going to present on them, and he was also going to present on his trip to Croatia, but he is on travel in Oakland, and he ran into an pretty bad issue with his computer and other computers in Oakland, California. I won't go into the details, but he may or may not be here today, thinking he won't be. So some of the things that he's going to present, we will table that until the December webinar. And that webinar is going to be, we're planning that right now. We potentially have a speaker, educator and students from New York who are actually part of our recent paper. And you may have seen for the Globe Trees Challenge, there was an Instagram reel and a YouTube short with Diana Denke and her students for last week's IG reel for the Trees Challenge. And then we'll have some final discussions, and then we'll adjourn. So I had to modify this a little bit since we're in year 5, and you can see we have a great number coming in from year 5 already, and that just started October 1st of this year. And we already have 1,551 measurements from over 2,000 global sites. You can see, of course, the tree height measurements are leading because we are right now in the middle, towards the end of the Trees Challenge, which I'll go over in a little bit. But you can see there's a lot of information there. The full campaign, we have almost 130 observations from over 45,700 global sites since the beginning of the campaign. So, as you know, what we do often, we look at change over time. So this is a lot of data for just over 4 years of the campaign for tree height, land cover, and greenings, green up and green down. So we really love the students who are participating in the campaign with their teachers, to do some development of the research projects by looking at this data. We want them to look at all the Globe data throughout the life of the Globe program since back in 94, 95. But, if we want to get campaign specific, we look at the last, just over 4 years, and this is the number of observations that we have. And we currently have participants from 60 countries. So with that said, right now, we are in the final week of the NASA Globe Trees Challenge 2022, Trees in a Changing Climate. It officially ends this Friday, the 11th of November, but you will have until the 15th of November to get your data in that you collected from October 11th to November 11th. Because some of you, if you do observations in an area where their cell signal might not be that great, you can, you might have had it stored in your phone, but make sure you get that submitted, for this time period. So once we get to the 15th, we can do accurate metrics for the actual challenge. And we have some great numbers coming in. All right. So this is how you can participate. There's a URL to learn more about it. As you know, I know a lot of you who are on this webinar have actually taken the observations so far. So, but continue those. Thank you for the ones you've taken. Continue those. You know, we're looking for as many tree heights as we can, and also if you have a tape measure with you, you know, do the tree circumference as well, because all that data helps us understand a little bit more about, you know, the whole biomass and how much carbon intake the trees are pulling in from the atmosphere and potentially sequestering, you know, in their trunks, roots, branches, leaves, all those things. So right now, here is where all the participant countries are coming from for the Trees Challenge. There are 53 countries in the GLOBE program that have submitted data for the Trees Challenge. And those numbers right now are totaling 3,926 tree height observations from 1,390 locations across the globe. So as you can see, we're getting in a lot of data. There's a lot of open spots there, of course, but we're getting in data from a lot of countries. So that's super exciting to see. So we're super excited about that. So thank you all. You know, when we first started the challenge, in my head, I was hoping for 4,000 tree height observations. And with 4 days to go, you know, we're definitely going to hit 4,000. So we're super excited about that. So thank you all for that. So let me now go over what we're going to hear for our featured presentation. Our featured presentation is studying tree height and carbon of the Marmontova Aleja, or the plane trees in Dubovac, Croatia. And the educator in charge here is Snježana Zoraja, and she has students with her, Josip, Anja, Maxim from the Dubovac Primary School in Karlovac. And they're going to be talking about student research by example and the research they have been doing. And I got a chance to take a look at their presentation ahead of time, and it is absolutely amazing and, you know, very detailed. So this is, you know, one of the great things about, you know, this presentation you're about to see is that, you know, it's a combination of collecting the data, analyzing the data, and making sense of this data in the real world for real world applications. So you can see here, there's a couple of pictures that they shared. You'll see these pictures again, most likely in the presentation of them doing some tree height observations and tree circumference observations. But let me stop sharing my screen and pass it over to Snježana and her students.
Hi. Hi, everyone. Can you hear me?
Yep, sounds good.
Okay, I'm Snježana, my students. Come on, students. And we can share our presentation and our research project. Share. Can you see this? Can you see?
Yes, it looks good. Just put it in presenter mode if you would. That if you want to do that.
Can you see screen?
Yep, we see your screen. Yep. Can you put it in presenter mode? It should we see that.
Okay. Okay, this is our research project, and we present this project. First, I'm Snježana Zoraja. I'm a GLOBE teacher in Dubovac Primary School. I am also a science, biology, and chemistry teacher. Science, biology, and chemistry teacher. I have been working in GLOBE since 2005. On first slide, you can see our city, a map of our city. And on the picture right up, this is the oldest part of our city named Karlovac Star, because Karlovac was built in 16th century as a fortress to defend against the Ottoman Empire. Today, this is a map of Karlovac today, and this is Karlovac Star. Our school is here. You can see Primorska Street and Marmont Alley Street. Our school is here, and our students live in this area, and they go to school every day on those roads. 2019, yes, the big construction work began in Marmontelli. So the students noticed these changes, the changes on the tree, and we decided to show the citizen that we must save the trees, and we must show the citizens importance of this valley and importance of each tree. We started to measure, or we started this project in April 2021, and we finished in September 2021. 2022, we finished research project, and in May 2022, we present this project on national competition in Croatia, and this project was awarded with first prize. This is our school. This is our GLOBE atmospheric station. This is our phenological measurement, lilac and birch. This is our biometric GLOBE station, hydrology station on the river Kupa. And you can see on this picture, this is fifth class. The students learn about atmosphere. And our project, Marmontelli.
Snježana,
Yes.
we don't see the slides, the next slide. We're still on the first slide.
Okay.
Yeah, it's still showing the first slide.
Now?
Nope, still see the first slide, unfortunately. Oh, yep, yeah, I just saw it when you got it. Try to share again.
I share again.
Yeah. Sometimes Zoom likes to do that type of stuff.
Do you see now?
All right, you're on the first slide. If you maybe click on just on the second slide or share it full screen, maybe.
Yes, we share full screen.
We only see the present, we see the kind of like the working mode.
Do you see now?
Yep, now it's on the second slide with the multiple.
You can see presenting mode.
Do you see now?
Yep, we see the second slide. It's still on the not on presenter mode.
It's still on working mode.
Onda ćemo tako. Stavi drugi slide. Do you see this slide, second slide?
Yeah, we see the second slide, but it's not in presenter mode yet. It's all we see the slides on the left side, the column, and we see the slide in the middle, but it's on, you have it on the slide.
And now? Do you see now?
We see the second slide, but it's still not in presenter mode.
We don't know how to make this. We try to fix it.
If you look at Petra, she put a comment in the chat box. Maybe that will help out.
Povećajte u kaj vam kaže u chatu. Ne.
Dobro znam ja to da nije u prezentacijskom načinu, to smo skužili prije. Pa mi je ovo upaljeni zvuk.
Da. Dobro, pa sad spusti dolje. Jer nisi šerao to.
Ne, još. Evo prvo ovako. I sada ćemo probati šerati. Ovo. Now.
Do you see first slide now?
Yes, we do.
Okay.
Presenter mode.
In present mode.
Yes, it's in present mode now. Yep. Can you click to the next one just to see if it,
next slide. Next slide. Do you see next slide? Second slide.
Yep. Looks good. Looks good. Thank you.
I repeat. First picture. First picture. This is our school. This picture showed our GLOBE atmospheric station. This picture shows phenology measurement on lilac and birch. This picture showed the biometric GLOBE station and the students of 7th class. On this picture is our hydrology GLOBE station, and this is 5th class students learn about atmosphere in front of the school. Do you see third slide?
Yes, looks good.
Super. You can see the name and name of our research project. This project was named Marmontelli. This picture on slide is a photo from 18th century in Karlovac, and Marmontelli look like in a sunrise in 18th century. We present today about our research project, and my students, Josip, Luka, not Anja. Anja is not here, unfortunately, and Maxim present this project. And here start. Luka.
Okay. Hello. The research questions. Marmontova Alea is a plane tree alley near the Dubovac Primary School. It was planted from 1809 to 1811. It covers the ground from Karlovac, Dubovac, Grobničko Polje, and Rijeka during the construction of the Elysiana Road. It is from Karlovac to Rijeka. In Karlovac, the road begins with the plane tree line, named in the honor of the Marshal Marmont. It was built from 1774 until 1852, from the Napoleon Bonaparte's age. The alley is a monument of park architecture from 1968. In June 2019, the construction had begun on the road D6, which begins with the Marmontova Alea in Karlovac and concerns the community about possible tree damage. Research questions. What is the biological importance of Marmontova Alea for Dubovac and the city of Karlovac? How much carbon dioxide is absorbed during the life of trees, and what is the amount of carbon stored in trees? How much oxygen does one plane tree produce in one day? Why is it important for us to protect this tree line? On the picture on the right, you can see the construction. Hypothesis. Marmontova Alea is an important biological factor in the city of Karlovac and the city's district Dubovac, because the plane trees have absorbed large amounts of carbon during their existence, which is especially important due to the intensive traffic and burning of fossil fuels. One plane tree produces significant amounts of oxygen in one day during the growing season. The vegetation season of plane trees lasts from April to November. Research period, March until December 2021. The total number of trees in the alley, 102. As you can see in the picture, every tree has its own number, and our school is right beside it. GLOBE protocols. Biometry for 102 plane trees. Location determination, tree height, plant species identification, circumference of wood, observation and recording of budding and greening. We can see on these both pictures that our students are measuring the tree's height and circumference. Tree age is tree age is equal to tree circumference over the 1 year growth. 1 year growth of the plane tree is equal to 2.75 centimeters per year. Fresh mass, green weight in kilograms. We used this formula to calculate the green weight if the diameter is greater than 28 centimeters. or this formula if the D is less than 28 diameter is less than 28 centimeters. Dry mass, dry weight. We used this formula to calculate dry weight, which is green weight divided by 2. Amount of absorbed carbon. Carbon storage is equal to dry weight divided by 2. Absorbed CO2 in the lifetime of a tree is equal to carbon storage times 3.67. We use this formula, which is tree circumference divided by pi, to calculate the chest diameter of a tree in centimeters. The amount of oxygen produced in one plane tree of average size. We determined the number of leaves in 1 cubic decimeter. We're determining the leaf area. 1 square centimeter of tree leaves produces 0.05 milliliters of oxygen in 1 hour at ideal temperature and pressure with optimal humidity. Calculation of the volume of oxygen produced in 1 cubic decimeter. Calculating the tree canopy volume of the average plane tree. Calculating the volume of oxygen produced for one tree in 1 day. We can see on the second picture an leaf of average size.
On the picture is table with all the measured values for 102 plane trees and all the calculated values: age, green weight, dry weight, stored carbon, chest diameter, and absorbed CO2. These are the values we got. Average tree height is 17.48 meters. Average tree age is 67.23 years. Total mass of a living tree, green weight, is more than 333 tons. Total dry mass, dry weight, is more than 256.5 tons. Total mass of stored carbon is more than 85 tons, and total mass of stored CO2 is more than 297 tons. We picked and compared 3 trees of different ages. First tree had 37 years, second 61 years, and third 152 years. It's noticeable that with age, gross circumference, diameter, tree height, green weight, dry weight, carbon storage, and absorbed CO2. Tree height grows just a little, and every other value grows really much. Values especially grow for older trees, which shows significance of older trees, which have absorbed large amounts of CO2 through their life. Here we can see dependence of absorbed CO2 on chest diameter in trees. On x-axis is diameter, and on y-axis is absorbed CO2. Literature says that absorbed CO2 should grow exponentially with diameter, and so show our results. Green dots are plane trees. In 1 cubic decimeter, there were 2 leaves, and total leaf surface of those 2 leaves was 160 square centimeters. Total volume of oxygen in 1 cubic decimeter was we calculated by multiplying total leaf surface by 0.05 milliliters of oxygen in 1 hour, and we got 8 milliliters of oxygen in 1 hour. We calculated volume of tree canopy using a mathematical formula for calculating volume of cylinder, and we got 1003.07 cubic meters. We calculated the volume of produced oxygen in tree canopy in 1 hour, by multiplying volume of tree canopy with 8 milliliters of oxygen in 1 hour and got 8,024.56 liters of oxygen in 1 hour. If they lasted 8 hours and conditions were ideal, one tree would produce 64,196.2 liters of oxygen a day. Here we can see beginning of vegetation period for observed tree plane tree. It started to bud in April, and leaves were growing until May when they reached their full size. Here we can see end of vegetation period for observed tree. We can see all the colors that the leaves had, and it ended in November and December when all leaves fell off.
These are our conclusions. The hypothesis about the biological importance of the Marmontova alea of the city Karlovac and the city's district Dubovac was confirmed by the results of the research. Plane trees have absorbed more than 200 tons of CO2 during their existence. They contain more than 80 tons of stored carbon, thus removing that amount of carbon from the atmosphere. The tree-lined avenue contributes to the reduction of the greenhouse effect, especially when CO2 absorption occurs at the site of its intensive formation. If ideal conditions lasted 8 hours a day, one tree of average size could produce approximately more than 60,000 liters of oxygen, and the vegetation period lasts from April to November. It was not possible to use the GLOBE pH calculator to calculate the age of the plane tree because there was no option to calculate the age and amount of carbon stored in the plane trees. It is not possible to accurately calculate the amount of oxygen produced in 1 hour a day because photosynthesis depends on many factors: temperature, humidity, and light intensity, which can change within 1 day or hour. It is not possible to accurately calculate the amount of oxygen produced per centimeter squared because the values change between each plane tree. The following studies should measure atmospheric factors, cloud, temperature, and humidity in order to calculate the approximate amount of oxygen in ideal conditions during the growing season from April to November. The project is familiar with the Natura Viva in Karlovac, who take care of the protected alley. We presented this project to the local community. These are our sources in literature, and thanks for your attention.
Hey, thank you so much. That was a great presentation. And I'm going to open it now to any questions for the students right now. Everybody, if you want to, you can unmute and ask any questions. If not, you can put them in the chat. I have a couple questions that people sent me privately that I will ask, but I will open it up first to anyone. And don't be shy, because we're informal here. So, anybody have any questions? Don't make me ask all the questions. Anybody want to unmute? There's one question in the chat from Kay Zewitz. It says, how will this affect the plans for road construction? Any ideas on that?
Yes, the road construction has ended in that part of the city, and they planted new trees, and it's relatively better.
Excellent, thank you. While people are thinking, let me ask one of the questions that I received. Were you surprised to see the amount of carbon the trees stored and the amount of oxygen that the trees produced? Were they close to what you thought they would be before you did the calculations?
Yes, we were very surprised. We thought it was much smaller amount.
And that is why we should keep the trees healthy.
Yes.
Yeah, I was surprised to see in your one chart, I don't remember what slide number that was, but where you had the mark of tree, you had the S11, S17, and S57. And it looked like, if you go between the S17 and the S57, oh yeah, you can go back to that. I thought it was pretty amazing that, yeah, that one right there. If you look at the tree height for S17, basically the 22.91 meters versus a S57, the 23.92 meters, that's not a huge difference in height. But then if you go and you look at the green weight of it, based upon the, tree circumference and the tree height that you've got, you see there's a huge difference in that green weight, and also, which leads to the different number, the big difference in numbers for the absorbed carbon dioxide per kilogram in the S17 versus S57. Were you surprised to see that? I know I definitely was.
We were also surprised, but then everything was like logical when we saw in literature that that absorbed CO2 should grow exponentially with diameter, and like trees stop growing, stop gaining height, but they never stop absorbing CO2.
Yeah, and I see that, the diameter, of course, of S17 was 54 centimeters versus 133 for S57. So that's as you know, a huge contributing factor to the amount of carbon storage and absorbed CO2. So yeah, that's pretty amazing that, they're relatively the same height, but, you can see that the diameter of the one is a lot, it's over double the amount of the other one, almost triple. All right, there's a couple other questions here in the chat. All right, question, let me go back. Wow, there's a lot of them, very cool. All right, from Petra, how long did you observe the trees? How long have you been doing the project?
November.
Yes.
From we
April.
measured from April 2021 to November 2021. Then we made the project for national competition 2022 in May.
All right. Thank you. Another question coming in. This is from Valerie at NASA Goddard. She says, wonderful presentation. Can you go over again how you calculated how much carbon the tree stored? Maybe just go over a couple of those, the green, like little equations that you had there in the slide, a couple slides before.
So here we can see this, how we calculated carbon storage. So dry weight divided by 2, and dry weight is calculated by green weight divided by 2, which is calculated with this formula. We have diameter squared times height, and this coefficient if diameter is greater than 28 centimeters, and this coefficient if diameter is less than 28 centimeters. And like that, we calculated carbon storage.
Carbon storage multiplied with coefficient
is absorbed CO2.
Thank you, that's helpful. And so the different coefficient for the larger diameter trees is what you all just talked about, right? That the older trees are producing more or are storing more carbon? Was your result?
Yes, older trees are storing more carbon and absorbing more CO2 also.
Wow, that's a wonderful finding.
Yeah, that's awesome.
Thank you. Thank you so much.
All right, let's go to another question from Kay Ziewitz again. From your results, what do you have to say about the biological value of losing old trees versus planting new trees? I wonder how long it would take the new plantings to catch up to the productivity of the older trees. Any thoughts on that? Let me read that again. what do you have to say about the biological value of losing old trees versus planting new trees?
Biological value is very important, but we must cut old trees. We must cut ill trees. And Natura Viva, the institution in Karlovac, take care about this alley, about each tree, and sometimes we must cut some trees and plant the new tree.
All right.
If you
And this one, this other question kind of goes along with the question prior to that one. How did you find the rates for CO2 absorption and O2 release for specific tree species? Meaning, you know, where did you find the information that you could find this information on how to calculate these for specific tree species?
we found this information exactly. We found sources on the internet, and we taken this information from UK Wells sources. You can see in literature sources. Right. You can see on
Slide
last
one.
slide.
Second slide.
All good.
Can you see?
Oh, the window is closed. Share and stop our screen.
Wait a second.
Can you see this slide?
Yes.
This Friends and Brands 2021, how calculate the CO2 fluids and zone, oxygen production by plants. This is from UK. We taken this in research for our research.
Excellent. Two great sources there. Thank you. All right. Does anybody have any more questions? I think I covered all the ones that I received that I had and ones that were in the chat. Let me let's see. I think that was it. Does anybody have any last questions for the students? And you can go ahead and unmute if you like.
Okay.
Anyone else?
Oh, no.
All right. Well, thank you to Snježana and your students for presenting. This has been wonderful. Yeah, so we love to see this combination of collecting the data, looking at the data over time, but then also analyzing that data for it to make sense in the real world and have real world applications in local communities. Because when we see this happening, you know, as part of research projects, it really serves as a catalyst for other students around the world, around the GLOBE program, and not just the Trees Around the Globe Student Research Campaign, but other campaigns, to see that their observations matter in the real world, that people are actually using these, and that in the analysis of this data that you're collecting can be used to solve real world problems. So this is one of the amazing things with the GLOBE program, you know, that allows us to do this. So thank you all so much. And if anybody has any questions, you know, please feel free to put them in the chat. So right now, what I'm going to do is, I don't see Autumn Burdick on yet. I pinged her, but just haven't heard from her yet. She may have had some issues logging in, but I'm going to pass it over to Peder Nelson, and he is going to, you know, talk a little bit about the online things and, you know, potentially Pecora. So if you could unshare, Snježana, if you could unshare your screen so Peder can pop on. And then if Autumn joins us, we will bring her in after Peder talks with all of us. So thank you. Peder, all yours.
Thanks. Thanks, Brian. And thanks everybody for sharing that. It's really exciting to see how trees empower communities and how people care about the trees around them. And this conversion between tree height and tree species into things like the carbon cycle are really important and challenging to do. You know, that question about how did you come up with those equations without burning up the tree, or you know, doing some destructive way of measuring that, is part of the challenge that we have here in science. And so we use a lot of different techniques to try to estimate the carbon cycle, the water cycle, and all of the different pieces that are part of that, including trees at different stages of their life. And so that question about how the carbon cycle and trees change throughout their life is a really interesting one, because part of what we want to think about is the conditions that created the environment for that tree to actually live there, which actually does require a certain amount of soil buildup, right? Actually having carbon in the soil, having other nutrients that are available to a tree so that it can grow. That's a really important thing when we start asking questions about why do we have trees in these locations. And so soil preparation or tree planting preparation might be something that you actually do before that area is ripe or the best place that a tree can actually grow. Trees are long-lived. And so one of the things that also goes along with that is that they can be part of the carbon cycle for a long period of time, doing photosynthesis, storing that carbon over multiple years. And then importantly, we want to think about what happens if that tree falls down, right? And how long does a tree in the wild or in nature take to actually decompose into what is not recognizable as a tree? That is all part of the tree cycle of life. And so I want to encourage us to think about what came before those trees, the environment that these trees are currently living in or living in during their lifespan when they're photosynthesizing. They have green leaves or brown leaves, but they keep coming back year after year for those deciduous ones. But then also thinking about that long-term carbon and the difference between if we burn that up, you know, through a fire and it immediately going to the atmosphere, versus a slow decaying sort of process that slowly releases that carbon back into the environment. That length of time is an important part of the carbon cycle. So, you know, this is one reason why we in this campaign talk about the life cycle of trees and why we not only care about where they're located today, but also these processes of what happens if a tree is no longer in that location. And so, you know, today I want to kind of highlight, you know, here we are starting our year 5 of our data campaign, and we can actually go back and look at some of the measurements that were made when we started almost 5 years ago. How are those trees growing? Are they getting wider with their canopy, or are they just getting taller? How are they actually changing over time? And how has the weather that they've been experiencing on a day-to-day basis actually shaped them? Right. So for me, I really appreciate the change over time aspect to trees, because it's really a fun aspect to appreciate time on a different scale like that. So I want to encourage people before we actually, you know, move on to some of looking at some of the data that we've created here, is to reflect on maybe some of those early measurements that you made in this campaign. Or if you weren't part of the campaign when we first started in year 1, you know, what other data did people measure at that time? Are those trees still there in that location? That helps us to be able to develop the equations that the students were highlighting, right? Looking at carbon or carbon change requires us to look at 2 or 3 different points in time. So I just want to start off here and really highlight that, you know, the incredible job that Brian has done bringing together a lot of tools and activities and resources for all of us to take advantage of, to focus in on the type of research question that we might have. We are highlighting a couple important tools that might give you a sense for a comparison that you can do, or a place where you can start looking and asking the question about, well, are my trees in my community on these maps? Are they represented on those maps? And then how do the measurements I make compare to these models that scientists are predicting at these locations? So I want to highlight again, kind of walking through some of the questions that we're wanting to promote this year. And so, you know, I really appreciate this getting started with your student research, because on here, we have some summaries that we went through last year, including what is the land cover of the 126 different GLOBE countries that we have out there. And so a question that I have automatically is, how does your community compare to these national level estimates? Do you have more trees or less trees in your area than your country, if you were to look at that as a whole? Right? So we provided a variety of these summaries that you can take advantage of and provide some context to your community in relationship to the larger region. And so, you know, again, these maps are really useful because they are giving us a point in time, right? They're making an estimate of, in this case, what is the dominant land cover? And we can see by where the green is on this map, where we expect to see trees. Now, what's great is that a lot of people are planting trees. So sometime between 2016 and 2019, when this map was made, there might have been some change. And this map might be out of date or might be incorrect for your location. You know, here is kind of looking at the country of Croatia. And so, you know, taking what we understood or were presented with about the number of trees in the community there, we can look at the overall shape and distribution of that tree height. And I'll just give a little tip here. Tree height is usually related to disturbances or related to the age of those trees. It's not a one-to-one relationship where every year equals a meter of growth. You know, that's where you have to look at the type of tree that is there. There's some that are really fast growing, some that are really slow going. But what's interesting when I look back at this graph here of Croatia, and I'm going to zoom in just a little bit here, you can see this curve of tree height, where there is a lot of young trees that were recently planted, most likely. And then there is this other hump of older trees, taller trees that are on the landscape. Where are they located? And why might there have been this dip, you know, in between the old trees and these younger trees? That's just a really interesting question that comes up when I start looking at maps like this. And so I want to, you know, maybe go out and do some measurements, right? So again, we're really just building on these learning activities that GLOBE has put together. So I want to highlight this for all those teachers and students out there. If you're wanting some methods for your research projects, use some of these learning activities of getting to know your satellite imagery. Do some sightseeing where you actually use the photos that you're taking, maybe through Globe Observer itself, of the tree, of the land cover that's around. Describe that carbon cycle. Put that tree into its dynamics. And there's a variety of other ways that you can analyze the land cover data, do some satellite interpretation. So I'll just highlight that. And then I also want to highlight this accuracy assessment tutorial. this is, I think, a really nice way that you can start looking at the data for your area in a systematic way. Again, it's really good to go out and make those individual measurements of those trees, but I think, Brian, correct me if I'm wrong, there is now a trillion tree challenge that's out there, where the goal for some groups is to have 1 trillion trees planted around the world. We're not going to be able to measure every single one of those, which is where remote sensing comes in. Okay, so I want to highlight this set of activities because it is full of methods that you can actually use. Okay, so with that, you know, I want to really go back and look at this GLOBE data, because it's really valuable. As we were seeing, there's visualizations and ways of exploring the data here, and this is, you know, a really good place to start off. And again, I want to just highlight that there is this satellite imagery inside of here. Okay, so this is the way that I like to look at the world, because again, where we see these dark green areas is typically where we're seeing the trees. Okay, and one of the places that I like to go back to and look at is our biosphere. You know, that green part, the living part of our cycle here. And I want to go in and I want to highlight, you know, some tree heights that have been submitted in, say, the last year. And, you know, and so one of the things that comes up is we automatically start to see a little bit of a pattern here of where we are not getting tree height observations. And there could be 2 reasons I'll just put forward here for this. One is there's no trees there, right? So this map is actually giving us an indication of where we might be seeing trees, which is our first question that we're interested in this campaign. Where are trees located? And what is a definition of that tree for your environment, right? And so this is the kind of, you know, where we've been getting data the last year. That tells us something about our world, and we might want to explore that a little bit more. And I do want to do that by actually zooming in on the satellite imagery, because one of the things that this database is really good for, and I'm just going to zoom in on no particular place, but follow this up to an area in Colorado. And one thing that I want to do is notice the imagery changed as I zoomed in. And I want to encourage you to really do this. Get in and see the high resolution imagery that is available to us coming from Bing and Microsoft. And I want you to sort of pay attention to where the point is located in relation to the actual trees that we can see in the satellite imagery. And one thing I'll highlight is in this area, it looks like there were 2 trees that were measured, but I can count many trees in this area, right? So this is one place that we can go in and we can look at where the trees are located. Some comments. Looks like this tree is 11 meters tall. And then we have this photo. Again, you know, this photo, you know, gives us the context of this tree, right? So one thing that I noticed with this particular tree is that I see a lot of sky, which means that there's not a lot of trees, or they're spread out, right? A little bit of context for this tree. And so I can actually start to understand this particular area. And I can see that it looks like there's grass here, but when I look at the satellite imagery, I maybe see this grass right here, right? So I'm going to try to understand this using the satellite imagery and what's on the ground. Now I want to highlight that when we're doing this, one of the things that we're noticing is as trees get taller, we see more and more shadow with our imagery. And so that's an indication right there that we can use to estimate tree height from satellite imagery. We can track that tree growth over time, because that shadow is part of what the satellite imagery is recording. So it's good and helpful to explore individual trees like this, but it's going to be really hard to understand the full, community here. If I zoom out, I only have 2 trees that have been measured in this area. So to kind of end our demonstration today, I want to highlight a tool that you can use to estimate the number of trees that are in your community. And this is something that came from our earlier on in our campaign. And there is this tool called iTree. And so this is a tool that allows us to collect some information. And there's a tutorial here that will guide you through a little bit more about it. But I'm going to quickly demonstrate how to go from those individual measurements to actually making some more community level estimates of how many trees are in our area. This tool I'm highlighting because it does provide some additional information about carbon dioxide or air pollution or some other features if you're in the right country, okay? But the tool itself for estimating tree canopy can be used globally. And so you can go ahead and use it if you're in Croatia, or whether you're in Switzerland, or whether you are in Brazil or Argentina. And this is a tool that the USDA Forest Service has developed, and I want to restart this. It looks like I am needing to restart my project here. Sorry about this. And so I'm going to clear this because it looks like it was stuck in my browser. So that's kind of useful. Okay. And I'm going to come in here and do a new one, start over. So the nice thing is this is all using a browser. So it should work. Yes, okay, this is what I wanted to show everybody. When you come in here, you can quickly define what is the area that you want to estimate the canopy cover. So how much of the area is covered by or has trees in it from this satellite view. Now you can load up your own, you can draw a boundary on a map, or you can look at a couple predefined areas. So here I am just going to choose, and I'm going to look at a particular state. So I'm going to turn that on, and I'm going to look at the state of Oregon. So I can just go in here and select that area, and I am now going to use that for my area of interest. That's going to be my study area. And I only want to look at whether there's trees in that location or not trees. So with that, I can just turn on this binary. Is it going to be a tree or not tree? And just choose the defaults. Kind of makes it nice and easy in this way. This next piece is if you want to learn a little bit more about the carbon or some other aspect to the benefits of trees in that area. Now, again, this only works in these 3 countries, the United States of America, United Kingdom, and Sweden. So, I'm going to go ahead and not choose a location, because I will demonstrate this without making that selection. But if you're in one of these locations, there are some lookup tables already available to you that can provide some benefits. This is where there's opportunities to contribute and maybe add Croatia or some other locations to this to extend this out. But here I'm really only using it to make an estimate of tree canopy in my area. And this does some statistics and some summaries for me, which is why I wanted to show it to you, because we really want you to do a little bit of math. and summarize a little bit, like we were seeing earlier from Croatia itself, what you can do when you start bringing in some other context and some other information. So all you have to do is click on the little plus, and it puts you in a random location, in this case, in the state of Oregon in the United States. And all I'm trying to do is, for this location, answer the question, is there a tree there or not tree? And here, I've spent a lot of time looking at these, but one thing I can see is there's green. So that usually indicates a tree. And then I can see this sort of shadow or black thing that goes off of it. And that's the two things I'm looking for to identify this as a tree. So from my understanding of this area, seeing this black, kind of zooming out, getting a little bit of context, I can start to see the cone shape of these trees compared to grass or low shrubs. Grass doesn't have shadow, so you don't see that black, and shrubs tend to be this mottled or kind of texture, but usually you don't see that black streak that goes along with it. So that's how I identify a tree from the aerial image, and I will label this as tree. I get the location of it here, so I could write that down, or I can keep going through and I can create a table, which we can then use and analyze later on. So that's what I'm going to do. I'm not going to write this down myself. I'm going to do this save and create. So you notice now I get a percent covered, I get an estimate for the area of tree covered, and I get another location on the map. So I'm just going to keep going through and label these locations. This is not a tree. And so I'll go through, and you can start to see that my percentages and my estimates of how much of my area in Oregon is tree cover versus not tree cover. And so I can keep going through, and I want to zoom in a lot of these places, and you're just doing this point estimate, and this is not a tree. It's near a tree, but it's not a tree. So I'll choose that one. Again, not a tree. And so this is what a scientist does. They spend a lot of their time going through and looking at point locations and labeling them, in this case, of tree and not tree. And one of the things that happens, the more of these locations that I label, the better my estimate of that tree cover is. And so here, this is kind of a little bit more of a tricky one, but I'll come in and label that as a tree. And again, I'll finish up here with doing a final one, number 10 here. Again, not a tree. These are areas in Oregon that might be a tree. It's hard to really tell, right? So that's part of why we want you to go out and make these measurements, is because from the aerial view, sometimes I can't zoom in far enough. I don't maybe have enough resolution of my imagery. Like, this is kind of blurry. And so it makes it hard to know for sure of what I'm seeing there. But I'm going to label this as not a tree. So I've done 10 labels. I have some estimate of how much my area is covered by trees. So I can just click on this report, and I get a report. And so this is something that you could reuse in your science report out to your community. Here I've got a map of my random locations here on the left. Here, this is the state of Oregon, kind of my area of interest. And we see that out of my 10 points, 70% of them were not trees, which is kind of interesting. And here I could show you the satellite imagery, and it makes some sense, right? Where it's brown, it sort of is brown on the map. Where it's green are the areas that I've found some trees. So that is a little bit of a nice assessment right there of what I'm seeing. And again, we have this error, or this variability around our how much of Oregon or this area is covered by trees, because I've only done 10 samples. So the more that you do, the more a representative sample you have of your area. Again, it might be really hard to go out and measure all of this because I would have to drive from here to here, and that's hours. I don't have the budget, I don't have the time. So that's where I'm using this satellite imagery as a way to understand a region, understand a larger area. And the nice thing is, you know, here I do get some summaries that I can use to report out, to compare to my measurements on the ground. And so this is a really helpful kind of summary report that I can actually print, I can download, and I can use for furtherance to understand the area. So let's see, if I scroll down. Yes, okay, so that's how you go in and you can do an estimate for your area. And so, you know, this is a really nice way that if you can't go out and measure those trees, figure out how big this tree canopy really is on the ground, you can do some remote sensing and you can get an estimate for how much area is covered by trees in your location, in your study area. So that I really wanted to show that to you today, you know, as a way of kind of helping you to get a sense for how you can do those individual tree measurements, and then how you can connect it to the satellite view where you can put those trees into context. And so, you know, another reason why I really like this tool is because you can actually save your data and you can get this list of your locations, your latitude, longitudes, and your labels. So you can use that table to look at what species is that tree that I labeled, or you can use it to then, as I'll demonstrate later on in our next presentations, is to then find out what is the height of those trees in those locations. And so, you know, so for me, this random location, random estimate, random labeling is a good first step in identifying where are trees located in my community or in my study area, and where are they not located. And then you can take that and combine it together with lots of other satellite imagery and data that we've highlighted in past webinars. And so that's what we'll be doing next, you know, to really enrich this first level of data, right? Which is, where are trees located in my community? And you can see it goes really, really fast to be able to make these point estimates in a location. And how big of an area that you want to study is something that we can address as well. As you saw, I can use some predefined areas, state, county, all kinds of things like that that are already pre-generated like that. Or you can actually draw your own areas of interest. And so we'll highlight that, you know, kind of going forward, because that, again, is something that you might want to do if you are concerned about your particular location. Or if, as you know, was asked, well, what if my country is not listed in this predefined locations? That's where you know, you can upload your own area and work on that for some Asia Pacific countries, for instance. And so, you know, Sonal, you know, this ability to define an area might require going out and identifying that outline, right, for the country. Or it might require a little bit of just finding an authoritative source and then bringing that into this tool to be able to identify that area of interest. That study area of interest definition is always that fun part of the first part of your project, because it sort of goes back to how much time do you have to spend. The smaller area, that geographic area that you are trying to study, the more data points that you might be able to produce, or the more trees that you can go out and you can actually measure on the ground. And, you know, but it also limits your ability to take those measurements and find other areas that are similar to it, right? And so there's always a trade-off that we have when we're trying to research an area. So, you know, one of the things that we did want to highlight is the sustainability goals that the United Nations have put together. And through that are policies that are getting implemented at a national level. So if you're wanting to understand or work at a national level, remote sensing tools are the only way that we can really do it effectively. And so sampling in the way that we've done here is how we actually scale from the local area up to a national level and a global level. It really is thinking or acting locally, making those measurements locally, or sampling locally, and then comparing it to those national levels. So here I will take us back to, again, you know, these summaries that we have already provided to you, you know, based on some other maps, but that help you to put your local area into a regional context where policies might be getting created related to these sustainability goals or other policies, right? We want to have so much tree canopy cover in my community by a certain time. And so here I've demonstrated two ways: the GLOBE database and the GLOBE tools, and then this using the satellite imagery to keep track of where trees are located and where trees are not located based on a particular data set. And again, I'll kind of go back, pay attention, whether you're in the GLOBE database or whether you're using a tool like this, what is the imagery that you're actually looking at? Because as we highlighted, things are changing over time. And those trees in this imagery may or may not be there in the, when you're making your measurements, or when you are trying to understand your local context, right? So I just kind of wanted to spend a little bit of time highlighting this two ways that you can start understanding where trees are located in your community. And then, in our next webinar, we'll really talk about, the stories behind those trees, right? Because this gets into how tall those trees are at this moment when you make your measurements is related to the stories of your community, right? And whether we allow those trees to continue growing to be the height that they are today, or whether they are impacted by some disturbance. And I'll put in there the vocabulary, agents of change. When we start thinking about trees and the life cycle of trees, because wind and people, and as well as insects and drought and other sort of agents are acting on those trees in our environment, and how tall they get to become is related to the agents of change in your particular community. And so next time we come back together, we'll go back and we'll look at this forest canopy height data that was created and relate that map of where we're finding trees to the canopy height that's related in those locations. Again, that does relate to the carbon cycle and how fast they're growing, and the other environmental variables that you might be able to measure that tell us something about why those trees were able to become as tall as they are. And do we see some interesting geographic patterns that might tell us why those trees were able to become so tall? And what did they experience during their lifetime that they can share with us? So come back. We want to encourage you to come back and put those trees into this context about why are they allowed to become as tall as they are, and what do we understand as we look at the different globe countries and those agents of change that are happening out there. So I hope that I've given you another insight into this connection between ground measurements and this remote sensing perspective that we can start putting together to understand our local environment and be able to come up with those allometric equations that help us to understand the carbon cycle and the water cycle in our area. So with that, I'm going to hand it back to you, Brian, to take us home for the last couple of minutes here of our Trees Around the Globe student research campaign.
All right, thank you, Peter. And you saw that there were those 2 questions in there, and you answered those perfectly. You know, Mike Jabal was asking about the lat long, and he said he asked it too soon because you covered that, not too long after he asked it. And yep, so great. So yep, so the last thing here, a couple things I want to show is Autumn Burdick cannot be with us today in person, but she will be here in December. But what I want to do is show you. Autumn sent me the video that is actually going to be premiering on YouTube in about 21 hours, and it's with the Globe Student Vloggers program. And I'm going to show you the first couple minutes of the video. It's very cool. So basically what happens here is that the student vloggers, and I don't want to give too much away because I know Autumn's going to talk about it next month a little bit more. But in the video, you're going to see that the student vloggers who were selected by the GLOBE program across the planet had an assignment to talk about trees with their elders, whether it could be a parent or a grandparent, and talk about how they've seen trees change over time. Do they see more trees or less trees? So this is, we're including this in the webinar because this is another way of research. This is talking to people about what they've seen over time. Okay, they're not specific measurements, but they're, kind of on that anecdotal scale. But they're the folks who have been around for longer than some of these longer than these student vloggers, they have seen changes in their environment, and this was a focus on changes looking at the trees. So let me go ahead and share my screen again and pop over to the YouTube video. And like I said, the video is going to debut in about 21 hours. But I'm going to show a couple minutes of it. It's almost 14 minutes long, so we don't have the time to show the entire thing. I'm just going to show you a little bit, and then it'll serve as a teaser for what Autumn's going to talk about in the December webinar, which the time and date specifically is to be determined because our speaker, Deanna Danke, and her students are finding the best time that she can juggle teaching and coming and presenting with her students. So we'll have that out pretty soon, that information. So let me go ahead and share this, and then we have one last thing after this, and then that will take us to the end of the webinar. All right, let me go ahead and share this. I'm going to show the first couple minutes of this. Peter, does this look okay on your screen? It's looking a little funky online, but I think it should be good.
Yeah, it looks good enough.
All right, cool. All right, let me start this, and this is about the student vlogger project, their assignment that they're doing right now.
Hello everyone, I am Snježana Zoraja, student from Thailand. Today I have the story about the number of trees and weather in my hometown with my grandmother. ยะบ้านเราเรื่องบ้านเราต้นไม้พื้นที่ที่เป็นป่าไม้แต่ก่อนกับตอนนี้เปลี่ยนแปลงไปมากมายเปลี่ยนแปลงอย่างไรบ้าง
แต่คนสียาเกิดมันเป็นป้าต่างเป็นต่างเป็นแปลงไปเยอะเดี๋ยวนี้ก็ไปทูดมันก็พลิกกันเป็นตรงเลยแบบแต่ก่อนเป็นตรงทับหน้าเดี๋ยวนี้จะตรงเป็นส่วนปาล์ม
แล้วก็จะสภาพอากาศในช่วงที่อยากเป็นเด็ก เป็นผู้ใหญ่เป็นแปลงอย่างไรบ้าง
อันเลยมันก็เหมือนมันไม่เปลี่ยนแปลงเลยครับครับ
เขาทราบเวลาน้ำท่วมแต่ก่อนกับตอนเนี้ยท่วมนั่นเหมือนกันไหม
เหมือนกันเหมือนเดิมอย่างเหมือนเดิมแล้วน้ำท่วมเหมือนเดิมมันเลยท่วมแต่ก่อนกันเหมือนกันเลยแต่ถ้ามันเนี่ยแบบว่ามันนี่ท่วมเร็วว่าแต่ก่อนเลยว่าติดน้นติดชนประทานมันติดดุนท่วมเร็วว่า
มาสิยายคิดว่าชาวบ้านเราป่าไม้เป็นแปลงสภาพอากาศเปลี่ยนสภาพความเป็นอยู่หรือประเพณีบ้านเราเปลี่ยนไปไหม
I live in Slima. I've been in Slima for the past 40 years. Slima was well known for its private gardens. As such, the trees haven't changed per se, but the trees have been replaced by, unfortunately, lots of apartments. We've lost loads of gardens in Slima. They were fabulous houses and fabulous gardens. Unfortunately, everything's been lost to high-rise apartments, building all over the gardens. So, yes, we've had the loss of trees within our town, and with it as well, loss of biodiversity. So it's not losing just the plants, but also losing the insects and animals and anything that lives in these private gardens. It's getting hotter, as we know. In summer, having more heat waves than we used to have when I was younger. Rain is reducing. In fact, I'm trying to keep track. I think this is the seventh. We had the 7 consecutive winters with reduced rainfall. So normally in Malta, in a year, it rains about 600 millimeters. We're not always reaching that bracket of rain. Also having dry spells in winter. So sometimes, even over here, we had to water our plants in January. So normally in January, February, it does rain, so we don't need to water our plants. But for the past 2 years, 3 years, we've been watering our own plants in winter again, in winter as well. It's all the effect of, I believe, global warming and the desertification process of the island of Malta. When we're driving around, we normally see the same 4 or 5 trees. We see maybe the pine and olive trees, but we have 60 different tree species in Malta. Many are, some are extinct. Some have lost the female counterpart, so just males. Others are a bit rare. Some are quite common. For example, the Aleppo pine, the pine is quite common. The calyx is quite common. Olives, they're becoming very common. But with some fabulous and nice trees, which I think we should promote them more, even if it's along our roads.
All right, I'm going to go ahead and stop that now. I'm going to hop over to the last thing I want to discuss. And this would be, let me pop here. All right. So, and this is just going to be a quick intro, and then Peter Falcon is going to talk about this at the December webinar. But one of the things that we want to do, and that the GLOBE program, Tony Murphy and his colleagues want to include in a lot of in the campaigns and a lot of things that we're doing with GLOBE, is to really look at the United Nations Sustainable Development Goals. And there are certain ones that the GLOBE program focuses on, and you can see quality education, clean water and sanitation, life below water, and life on land. And I won't go over all of this. Like I said, Peter Falk will talk about this a little bit more next time, but I want this to be on your radar screen for when we have the webinar, and see how it fits into our Trees Around the Globe Student Research Campaign, because we definitely, everything here, these 4 that are listed in this GLOBE program document, are ones that we really focus on with the campaign, from webinars to, the challenges, to the IOPs, intensive observation periods, to having the students and teachers present at the different webinars. So, but then also taking observations, and as we saw earlier from the students and Snježana in Croatia, talking about how they took it from observation to analysis to making it make sense in the real world and having real world results. And that's one of the most important things here, as one of these, as an extension of these sustainable development goals that the GLOBE program is incorporating into the larger program. So I just wanted to, touch base with you there. Like I said, we'll talk more about this because Peter was at a, at a meeting with the NARM, the North American Regional Meeting, and they talked about this a lot, but he apologizes that he can't be here today. So he will be talking about that and his recent trip to Croatia and the things that he did while he was there as part of the Europe and Eurasia Regional Meeting. So and some of the tree stuff, land cover stuff that they did there. So let me go ahead and stop sharing. And if there's any last minute questions, let me know. If not, we will adjourn until the next meeting in December, which is TBD. We're still waiting on those specific dates. But then also I will get this Zoom webinar up as soon as I can, once I get it back from Zoom, and I do a little bit of editing and get it up on the website. And then I'll send out an email with that information. So thank you everyone for the amazing presentation, especially Snježana and her students, as well as Peter for, once again, the amazing online tool discussion and where you can find this information. And we hope that all this, the online tool discussion, you and your students utilize this, because it's amazing stuff. And Peter has really taken the time to filter down what he thinks are the best tools to use for this type of research that we hope the students do, and specifically for upcoming IVSS. So yeah, so that's great. And Janelle, she said, is there a person that could help me get started? Yeah, we as a team, please contact us if you want to talk about like the online tools. Perhaps Peter, do you want to pop your email in the chat, and then we can get started in talking to Janelle about the online tools and things like that with the campaign. So I'll also put mine in here too. But yeah, thank you for that, and thank you for wanting to get started with that, Janelle. So that's great. So once again, this recording will be put up on the campaign webinar page soon. So thank you all very much, and until next time.